Hey guys, this is the screencast for section 9.3. So in this section, we're going to go a little bit more, the straightforward route. So what we're going to do is we're going to see how we can convert between polar forms and rectangular forms and vice versa. Okay. All right. So let's start off with the very, first thing. We're going to see how we can convert polar to rectangular. So if you have polar, how can you write that in rectangular coordinates? Okay, so here's what we're going to do. Suppose you are given r and theta. Okay, so you are given r, this one, and you're given theta, that one. Now, can you come up with a way, with an expression for x, and can you come up with an expression for y? So basically, what we have is, I have coordinates r comma theta, and I want to write them as x comma y, okay? All right, well, if I have r and theta, well, I can write an expression for x, right? This is x, and I can say, well, I know that cosine of theta is equal to x over r. So if I multiply both sides by r, then x is equal to r cosine theta. And we've done that before. This is r cosine theta. And what about y? Y is this, right? So if I say sine of theta is equal to y over r, then multiplying both sides by r, I can say that y is equal to r sine of theta. So this is r sine of theta, okay? And that pretty much, r cosine theta and r sine theta, which we've seen before again and again and again, is literally the key to this entire section. That's the bridge with which we can go from one universe of the rectangular coordinates to the other universe of the polar coordinates. Okay, so if I have this point here, then, right, there are two ways to describe that point. Okay, I can either say that point is at r comma theta, or I can say in xy coordinates, right, the xy coordinates are r cosine theta and r sine theta. Okay, let's do an example and see what we're talking about. Okay, if you ever wanted to put anything on a cheat sheet for these, right, it would be this and this. Okay, these are definitely cheat sheet worthy. Okay, all right, so here it says find the rectangular coordinates for each point with the given polar coordinates. Okay, all right, so basically what do I have here? I have r and I have theta. I want x comma y. Okay, let's just see what this looks like here. So if this is the polar axis, my angle here is an angle of pi over 3, like this. And this radius has a length of 2, so that's the point that I'm trying to describe. Okay, and this is the origin right here, or the pole. All right, so what you do is this. You say x is equal to r cosine theta, y is equal to r sine theta. So x is, literally just plug in r, 2 cosine theta pi over 3, okay? And so that's x is equal to 2. What's cosine of pi over 3? That's right, it's 1/2. So that's equal to x equal to 1. Well, what about y? Y is 2 sine pi over 3. Y is equal to 2 times sine of pi over 3 is root 3 over 2. So y is root 3. That means, what is the rectangular coordinates for this? 1 comma root 3. Okay, well, let's see if that makes sense. How much is root 3? It's about like 1.4. So, I'm sorry, 1.7. So does that make sense? Does it make sense to go from the origin, I go over 1 unit and up root 3? Yes, it does, right? So do you see how it's two different ways of representing the same location? Okay, fabulous. Let's do this one. This is the polar axis, right? Now I have -5 and 45 degrees. So 45 degrees, would sort of be here. But now this is -5, so it's in the opposite direction here. Okay, so that's a distance of 5, okay, in absolute values. And that's where my point P is, right here. Okay, so what we're going to do here is the following. We're going to say x is equal to r cosine theta, y is equal to r sine theta, x is equal to, you got to keep the negative, -5 cosine 45, x is -5 root 2 over 2, y -5 sine 45, -5 root 2 over 2. So the coordinates of f are -5 root 2 over 2, -5 root 2 over 2. Does that make sense to go from here, right? Does it make sense if we had a 45-degree angle that I go -5 root 2 over 2 and -5 root 2 over 2 to get to that point? Yes, it does. Okay, so that's how we convert from polar to rectangular. Okay. Oh my God, really? Like, it's asking me now if I'm enjoying Drawboard PDF? Yeah, thanks. Okay, let's go in the opposite direction. What if you have to go from rectangular to polar coordinates, right? So what if you're given x and y, but now you want to write it in terms of r and theta. So instead of saying go to the right 1 and up 3, you want to say, rotate in this angle and go out a certain degree. Well, so let's see how that works. Okay, so suppose you know x and y, right? So here you're given x comma y, okay? If you're given x comma y and you want to find r comma theta, right? Well, how would you find that red distance r? Well, that's easy. You just say r squared is equal to x squared plus y squared. So r is just the square root of x squared plus y squared. Good old Pythagoras. Okay? Well, then if you have the purple x and y, how would you find theta then? Well, isn't theta just, the inverse tangent, right? So tangent of theta is y over x. So theta is inverse tangent of y over x, right? But then we have to do a little bit of adjusting sometimes, depending on what angle we're at, okay? All right, so here it says to find 2 pairs of polar coordinates for each point. Let's start with one and then let's see if we need the other one, okay? Before we do that, however, here's what I want to talk about here. Well, no, you know what? Let's just go ahead and start. Okay, so, and it says round to the nearest hundredth if necessary. Okay, so let's remind ourselves of the unit circle for a minute. Okay? So do you remember that this is 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So we know that, okay, this is 0, and we know that this is pi, and what's the numerical value of pi? It's 3.14 radian, right? And that means that 2 pi is actually 6.28 radian, right? Okay, well, if pi is 3.14, right, has a numerical value of 3.14, what's pi over 2? Half a pi. Well, that's half of 3.14, 1.57. Okay? And then what's 3 pi over 2? Well, that's just 3 times, that's just 1.5 times 3.14. And that is 4.71. Okay? So if I say, right, something has an angle of, I don't know, pi over 6, that's right here. Okay? If I say something has an angle of, I don't know, 1.1 radian, right? Well, pi over 6, that's like 1.52. Well, where would, 0.52, where would, oh my phone isn't off. Where would 1.1 radian be? Oh, somewhere over there, right? So that's the numerical values, of the angle. So basically, if you just plugged in pi over 2 in your calculator, what number you would get. Okay? All right, so let's just go ahead and do this for a minute. Okay. I have here rectangular coordinates, x comma y, and I want to find r comma theta. Okay, so we just said r is the square root of x squared plus y squared. So 2 squared plus negative 4 squared. So r is the square root of 20, which is 2 root 5, which is about 4.47. We want to round to the nearest 100th here. Okay. Well, what about theta? Theta is inverse tangent of, what was it? Negative 4 over 2. So theta is equal to, inverse tangent is negative 1.11. Okay. Does that make sense? Right? Does that make sense that theta is negative 1.11 degrees? Where is that? Well, okay, so where is the coordinate 2 comma negative 4? If from this point I go over 2 and down negative 4, right? That's where my point is, right? Okay, and so now let's see if this makes sense. I have a theta here of negative 1.11. Theta of negative 1.11, that's right there about. And, okay, that's r, right? 4.47. So does that make sense that that's where theta would be? And that's where the angle would be? Yes, it does. So the coordinates here are 4.47, comma, negative 1.11. Okay. And I actually think I only want you to find one of these coordinates, not two. Okay, so let's just switch that to one pair. Okay, so let's do the next one. I have 1 comma negative 3, so that's x, that's y. R is going to be the square root of 1 squared plus negative will go away, root 3 squared. R is the square root of 1 plus 3, that's 4. So R is equal to 2. Okay, theta. Theta is the inverse tangent of negative root 3 over 1. Right? And how much is that? Well, wouldn't you know it? It's negative 1.05. Okay? So the coordinates would be 2 comma negative 1.05. Okay, so in the book too, if it asks you for 2 coordinates, just find the 1. All right? Okay, so that's so much for coordinates. Well, what about, if we wanted to do equations? How do we go from polar equations to rectangular equations and vice versa? Well, let's just take a look at, like how they feel, right? Let's just get a feel for them. So look at this. This is our standard old circle. Do you remember in polar form, the equation for a circle is r equals some constant? So if this is a circle with radius 3, then the polar equation is just simply r equals 3. Well, what's the equation in rectangular form of a circle? It's this, x squared plus y squared is equal to 9. Okay, what is this? This is the, if you remember, we did it in the SAT work, or, if you remember from geometry, this is the equation for a circle centered at the origin. And this number, okay, that's r squared, right? So this is a circle with radius of 3, right? So, that's just how they look. And then another one here, you have a rectangular equation, right? Look at this. That's just a regular old line, right? It's just y equals mx plus b. That's the equation for it. But now look at the polar equation, right? 6 over 2 cosine theta, and so on and so forth. So just to see that they do have completely different forms, right? And that's okay. So don't let that, make you think that you're doing anything wrong. All right. So let's just get right into it. These are actually fun. I kind of like these. So let's convert from rectangular to polar. All right. So remember that cheat sheet, right? Where I said x is r cosine theta, y is r sine theta. That's it. You're just going to replace x with r cosine theta, y with r sine theta. You simplify, 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 and then you get a cute little equation. Okay? All right. So let's take a look here. It says identify the graph of each equation, right? Basically say, what kind of graph do you predict this is, right? What shape is this? Well, since here, just like this one, we have x squared plus y squared in some form, right? X squared plus y squared. This is definitely a circle. Oh, that's not how you spell circle at all. This is a circle. The radius of this circle is 2 because it's the square root of that number. And guess what else I can predict based on what I've learned from, geometry and algebra 2 and all that stuff? I know that the circle has been shifted to the right 2 units, but there is no shift in the y because y is alone. So I know that the center is -2, 0. If some of that is foreign to you, that's okay. I'm just telling you based on what we see here, what we can predict. So basically, on the x and y coordinate plane, right? If you go to -2, 0, this is a circle with radius 2 and centered here. So that's pretty much how it looks. Okay? All right, well, let's see what the polar equation is going to look like. Okay. What we're going to do is we're going to replace all the x's with r cosine theta, all the y's with r sine theta. So here, x is going to be r cosine theta plus 2 squared plus y is r sine theta squared is equal to 4. All right. Next, we have to distribute the square here, right? So square the first term, r squared cosine squared theta, plus, please don't forget this inner term. 2 times 2 is 4r cosine theta, right? 2 times 2 times this. And then plus the last term is 4. So a squared plus 2ab plus b squared. Plus, squaring this, I get r squared sine squared theta equal to 4. Oh my God, it totally looks like things just got so complicated so quickly. But you know what? It's going to get so simple right now. Look at what we're going to do. I'm just, for fun, going to write these two next to each other. So just sort of shift things around. So I'm going to say r squared cosine squared theta plus r squared sine squared theta plus 4r cosine theta plus 4 is equal to 4. Okay, hey, do these 4's cancel? They do. They totally do. So now look at what happens here. From here, can I take out an r squared? Of course I can. Cosine squared theta plus sine squared theta. You can already see what's happening. What is cosine squared theta plus sine squared theta? That's just a 1. So here I have r squared times 1 plus 4r cosine theta is equal to 0. Now, let's divide everything by r. Why? Because we can. So now what I have is r plus 4 cosine theta is equal to 0. R is equal to negative 4 cosine theta, and that is my equation. That's it. That's my equation. Okay. What is this? R equals a cosine theta, right? So now this has the form R equals a cosine theta. Hey, is that the equation of a circle? That is the equation of a circle. What's more, if it's cosine theta, it lies along the horizontal axis. What's more, this says it has a diameter of 4. But is that right? Wait, yes it is, because my circle was supposed to have a radius of 2 with a diameter of 4. And the negative says it's on the negative side, right? So basically, this starts here. It goes 1, 2, 3, 4, right? Diameter of 4. And basically, it's a circle that looks like that. Okay? Plain and simple. And there you have it. That's what we've just done. All right, let's do another one. 2xy is equal to 4. Basically what I've tried here is I've tried to put one of every type that you will see. So let's just go through them because different types will have different methods of solving. So here I have 2. What's x? R cosine theta. What's y? R sine theta. Equal to 4. Now, I really know that you have every single urge to divide both sides by 2, but please, I'm telling you, resist that urge for a little bit, because check out what we're going to do right now. This is going to be 2, combining the r's, r squared, sine theta, cosine theta is equal to 4. And now I'm just going to flip the place of the r squared and the 2. I'm just going to, swap them. R squared times 2 sine theta cosine theta is equal to 4. But wait a minute, what's 2 sine theta cosine theta? That's from chapter 5. That is a double angle identity. That's actually sine of 2 theta. So what I have here is r squared times sine of 2 theta is equal to 4. Okay, and now what do I do with this? You have to solve it for either r or r squared. Okay, so you just say divide by sine 2 theta, divide by sine 2 theta, r squared is equal to 4 over sine 2 theta. And there you have it. And I'm not going to go over how to graph this one. And no, on the test, you're not going to have to either. Okay? There we have it. All right, let's do one more. Y equals x squared. Okay, we know this. What kind of shape is this? It's a parabola. Okay, so what about this next one here? We're going to do y is r sine theta equal to x r cosine theta quantity squared. Okay, now distribute the square, so you have r sine theta equal to r squared cosine squared theta. Now we have the situation of we have an r on one side, r squared on the other side. Simplify this, divide both sides by r, so I get sine of theta is r cosine squared theta. And like I said before, you have to solve for either r or r squared. Well, let's divide both sides by cosine squared theta here. And what I get is r is equal to sine of theta over cosine squared theta. The convention is to split this up, right? Because you have two cosines on the bottom, so do sine theta over one of the cosines times 1 over the other cosine, right? So do you see how it's the same? In the numerator, you have sine theta. In the denominator, you have cosine squared theta. It's just convention to do it this way. So if you see it this way in the answers from the textbook, you know what they're doing. And then that reduces to tangent of theta, secant of theta, okay? So they just want to like eliminate the fractions, that's all. But any of the forms is acceptable, like that one or that one, they're both acceptable. Okay, so last but not least, let's do converting from polar equations to rectangular equations. All right, so in this one, we're going to use the two that we were using before. X equals r cosine theta, y equals r sine theta. But then in addition to that, we're going to add to our toolbox, tangent of theta is y over x, right? So that's an option as well. And then one more thing that we might have to use, so let's add that on here, is r squared is equal to x squared plus y squared. That also comes up. Okay, so here I have theta is equal to pi over 4. All right, well, there isn't much I could do with this, right? So if you look at the repertoire, like if you look at the bank of equations up there, there is no r, so I can't use the first one or the second one. I can definitely not use the last one, r squared equals x squared plus y squared. Since there is a theta there, just a theta, maybe I could use tangent of theta. So what we do is if you have theta equals an angle like this, the proper thing to do is say tangent, you take the tangent of both sides. And hey, before we even do anything, here I have theta is equal to pi over 4. What should that look like? The graph of that, what should that look like? Theta equals pi over 4. Well, from what I remember from section 1, that should look like something like this, right? That's a linear equation, y equals mx plus b. So I would imagine that that's what my equation is gonna look like. All right, so let's take the tangent of both sides. So I get tangent of theta is equal to tangent of pi over 4. Okay. And now, what's tangent of theta from our equations here? Tangent of theta is equal to y over x. So what I do here, once I have the form tangent of theta, I take this out and in its place I put in y over x, because the two quantities tangent of theta and y over x are equal to each other, right? Equal to, what's tangent of pi over 4? 1. And so now if I solve for y, I get y equals x as the equation for that line. Does that make sense? Does y equals x give you a diagonal line like that with an angle of 45 degrees? Pi over 4? Yes, it does. So that's the equation for that. Okay. All right, let's do another one. If you have r equals a number, right? So we did theta equals a number. You do the tangent thing every single time. But now if you have r equals a number, the proper thing to do is you square both sides immediately. So that's what you do. When you have r equals a number, just square both sides. So now you have r squared is equal to 49. Let's just talk about background as to why we would even do that, right? So initially we had r equals 7. What kind of equation is that? R equals 7 in polar form. That's a circle, right? And what does a circle look like in terms of rectangular coordinates. The equation looks like x squared plus y squared. So for that, we need r squared. That's why we square both sides. Now that we squared both sides, I say, oh, wait a minute. I can't do much with the 49. But the r squared, right, that's equal to x squared plus y squared. And voila, you have the equation of a circle. You're done. This is it. Okay, and sure enough, just like we had up there, this is a circle with radius equal to 7. Okay. The next one. This one's a bit of a doozy. Okay. So here, I have r is equal to a sine theta. Okay. You remember this is also a circle, but this is a circle that is displaced. So negative sine theta, oh, that's not for you at all. That's my schedule of what to upload and when. Gotta stay organized. Okay, so this is a circle that's been displaced. So it's a circle that lies here. Okay, negative sine theta, a sine theta in the negatives. All right, so what we're gonna do, because it's r equals a sine theta. It's a circle. Again, you need r squared. So you're going to multiply both sides by r. And when you do that, you get r squared is equal to negative 5r sine theta. What's r squared equal to? X squared plus y squared equal to negative 5. And what's r sine theta? Y. So what you have here is x squared plus y squared plus 5y is equal to 0. And you can actually stop right there. That's actually sufficient to make it a circle. However, if you are asked to put it in standard form, right, in order to be able to see exactly where the circle is and what it looks like and so on and so forth, you have to do this cute little thing called completing the square. You guys remember that? Okay, completing the square. So if I have x squared plus y squared plus 5y is equal to 0, I have x squared alone, so I just leave it here. But look at this. This here, I'm going to group it. And I'm going to do y squared plus 5y plus a number equals 0 plus a number, right? Because whatever I add here, I got to add here. Well, how do I find that number? I take this 5. I always divide it by 2. And then I square it. And you know what? I'm going to be a rebel and convert it to decimals here and do 6.25. Okay, so now I can factor this guy, and I say x squared plus y plus 2.5 squared is equal to 6.25. Hey, how do I get 2.5 here? Because that's the square root of 6.25, right? And so now, does that look more like the equation of a circle? It does. X squared plus y squared equals some number. What does this tell you? That the radius has shifted down by 2.5 units right here. Okay, so that's what the circle looks like. And that's exactly what we had predicted before. Okay, awesome. All right, so I remember way back in the day, I had said that I was going to do a little bit of section 1 and then combine the second half of section 1 with the last lesson. Well, that's where we are right now. We're going to talk about polar distance. I normally would derive this, and it's like super, super cool. It kind of breaks my heart that I don't have time to derive it right now. Fine, okay? Fine. We're past it, okay? We're past it. Okay. Let's talk about distance. In polar coordinates, if you have x1, y1 and x2, y2, right? How do you find the distance? Distance is x2 minus x1 squared plus y2 minus y1 squared. Okay? The polar form of that is this. So the distances, if you have r and theta given, r1 squared plus r2 squared minus 2r1 r2 cosine theta 2 minus theta 1. Do you need to memorize that? Not really, because your test is open book. Okay? So let's do it. An air traffic controller is tracking two airplanes flying at the same altitude. That means height. The coordinates of the planes are 8, 60 degrees, 4, 300 degrees, where the directed distance is measured in miles. Okay, the distance between them. Sketch the graph of the situation. Okay, well, we have one which is at 8, 60. So for that, we're going to do 2, 4, 6, 8, 60. That's plane A. Another plane is at 4, 300, right there. Okay. We want to find the distance between them. Okay, now, just like we always had, x1, y1, x2, y2, now we have here r1, theta 1, r2, theta 2. And what is r1 and r2? Those are the distances from the pole to the respective points, r1, r2. Okay? All right. So let's find the distance between them. The distance is 8 squared plus 4 squared minus 2 times 8 times 4 times cosine of theta 2, 300, minus theta 1 of 60. Some of you are wondering, just like when you see a face in a crowd, you're like, oh my God, I've totally seen that face before. Who is it? Who is it? Who is it? Some of you are wondering to yourself, oh my God, I've totally seen this formula before. Where is it? Where is it? Where is it? This is the cousin of the law of cosines, right? I'm just going to spoil it for you. In the big math nirvana heaven place, all of these guys are related to each other. They are all related. Okay. All right, let's do it. So D is equal to, I know we can use our calculator for this one, but you know what? We're just going to do this by hand because why not? 8 squared plus 4 squared is 80 minus 64 cosine of 240. Let's pause here for a minute. What if somebody messed up and instead of doing theta 2 minus theta 1, they did theta 1 minus theta 2? Does it make a difference? Does it make a difference? So in this case, you would have gotten cosine of negative 240. But does that make a difference? It does not, because cosine is an even function. So that's the same as cosine of positive 240. So just like with rectangular coordinates, it doesn't matter which one your point 1 is, which one your point 2 is. It's the same with this, right? And it shouldn't matter. The distance should be the same whether you start from A and go to B or B and go to A. Okay? All right, isn't that funny how math works? All right, so D is 80 minus 64. Hey, what's cosine of 240? You can totally do that because it's from the unit circle. It happens to be negative 1/2. So this is 80 plus half of 64, which is the square root of 112. But if you wanted it in decimals, it would be 10.6 miles. All right, with that, I will leave you to it. That was a little bit of a long screencast. Sorry about that. Remember for the homework to go on the lesson plans and not this, because things have been modified big time. Okay? All right, thank you very much.